Hello everybody. This next video is a night flight on October 27th, 2024 between Saginaw Brown Airport in Michigan to Richard I. Bong Airport in Superior, Wisconsin. I was showcasing the PS Engineering intercom that I just got installed and the Garmin GFC500 autopilot that's installed, and some other general aviation questions, concerns, comments, just me blabbing about whatever in the airplane. It is a night flight, and it will work out. It works out really well. It looks good, sounds good. So stay tuned and let me know what you think in the comments. Subscribe to the channel and click that like button for me, okay? Do it. Do it now!
We got an estimated flight time of 1 hour and 25 minutes today. We're leveling off at 6,000 feet. I got some slight cirrus clouds up in the sky there. Otherwise, we got no turbulence today. Outside air temperature is 40 degrees, and estimated ground speed is 113 knots. Like I said, it's a level at 6,000. We're going over the northern part of Wisconsin right now. It's about 6:32 in the evening on October 27th, and that's what's going on today, wonderful people. So we're flying airplanes. This is the first night flight we're going to be doing recording here, so I'm kind of excited. So we'll see actually how well this audio looks here and video looks. The sound looks a lot better, and we'll see what's happening here. And before someone makes fun of me about that, it's okay. Otherwise, the sky looks amazing. There's a little bit of bumps, but it kind of keeps you awake. Or there's no we. There is I. I'm going to use the word I from this point forward. I am by myself. I am flying the airplane. Or I should say, the wonderful autopilot is flying the airplane today. Sirius XM on the top. You guys can't hear that because otherwise the magical YouTubes and whatnots.
2497, Minneapolis Center, hello.
The YouTubes and whatnots calls it copyrighted, and then they block out the audio. So it is what it is. I'm not too worried about that. But I figured out how to get rid of that. But yet I can have Sirius XM, so I'm ecstatic about that. I'm getting a little cold, so I'm going to turn on the heater there. Like I said, 42 degrees, and we got a vent open on the floor over on the left side here. And yeah, it's kind of exciting. Like I said, estimated hour, 29 minutes so far left. This is a Cessna 172, a Cessna 177 Cardinal RG.
Thank you, Central Wisconsin, altimeter 3012.
The RG stands for Retractable Gear Airplane. This is from 1972, so if you could do the math, that is 52 years old. Airplane just got out of annual here about a week ago. Had that done in Superior. And everything in the airplane looks really well. Having a little difficulty with the gear periodically coming up, but it's not really, it hasn't been an issue since. My wonderful mechanic IA guy took a peek at it, so that's good. Otherwise, the airplane is flying wonderfully. Burning right now 8.2 gallons an hour. That's that little gizmo down there at about 23 inches of manifold pressure and 2,300 RPM on the prop. The exhaust gas temperature is sitting at about 1,435 degrees. What that means is the temperature of the gas when it comes out of the cylinder, there's these little probes that sit about that far from the cylinder, and they embed their
305 Whiskey, Minneapolis Center, 2621.
They're actually drilled into the exhaust risers, and each one of them has a little probe in there. That's what we're seeing there. It's a sensor. The other number we see down here on the bottom, this is the cylinder head temperature, so another little probe that sits on the top of the cylinder. So, of course, the cylinders are horizontal, so the top is farthest out, and there's little probes that are stuck into each one of the top of the head of the cylinder. And what that does is it measures the temperature of each cylinder, and so we can know the temperature of the cylinder to see if we're at proper cooling or we're working the engine too hard, or if we're cooling the engine too much. That's one of the things, too, we're always watching. Oh, what else can I show you on that wonderful instrument there?
November 41, Quebec, change to my frequency 133.65.
13365, 184, Quebec. Minneapolis Center, Cardinal 1841, Quebec, level at 6.
41 Quebec, thank you. The Ryan altimeter is 3012.
3012, 184, Quebec.
Outcom 2497 is
What that was, wonderful people, is we're currently on currently being handed off for Minneapolis Center's sectors, and so each one of the little frequencies along the country all has different little frequencies, and so you'll go from one frequency to another one, to another one, to another one, but you're like, well, it's the same guy. Well, the individual actually monitors multiple different sectors, depending on workload in them particular sectors, and so that individual controller handed me from one frequency to another frequency, and that's what that handoff was. And so the first part of that was he wanted me to go to another frequency, so I switched that on my radio. And then I read back that frequency, switched it in my radio. Then I hit the button and I told them what altitude I'm level at. And then he read back a altimeter setting, which is a pressure, a barometric pressure at a nearby airfield. And I made sure that this matched what he told me, and I read it back. What that did was it made sure that everybody in this particular surrounding area of wherever he told that pressure is all at the same altitude, because all of our altimeters are based on pressure. Well, you adjust our altimeter to go to the field in question's barometric pressure, because of course the barometric pressure changes. And what we do is this is sort of like a calibration. And what this does is if the field is not exactly at sea level, which of course it never is, and the field is not exactly at this thing called a standard pressure, what this does is it makes it so we can adjust it based on whatever the current condition is. So then the altimeter reads what it would be at standard pressure is one of the ways I can explain it. What a standard pressure at sea level is 2992. And so if it's plus or minus, and then of course the altitude changes, of course the field is higher, maybe lower than the sea level, we have to compensate for that and adjust our altimeter for that particular field's altimeter setting. And so that's what we change here, and then that's what we change here. This one right here is my current flight's primary altimeter, and I change this first, and then I change this to match that. So that works. And altimeters, they have to be close to each other when it gets certified, but they're not always perfect. So what my rule of thumb is I pick one that's my primary instrument, my primary altitude, and then I tell the other one to match that one. That's how I do that process. Air traffic control, in this case, will tell me to switch and give me a different altimeter setting periodically. If I wasn't talking to anybody, I could tune in to a particular airport's weather and get the airport's barometric pressure and do it myself if I didn't want to talk to anybody. And some pilots choose to do that, and that's their right to do that. I choose not to do that. I like to talk to air traffic control every single time I fly, and let them tell me about traffic. Let them tell me about weather. Let them tell me about altimeter settings. I think it just works better that way, but people have opinions about that, and you can have an opinion. Let's see here. I'm drinking coffee from Frankenmuth, Michigan. This coffee is from Creation Coffee, and that's a local coffee shop in Frankenmuth, Michigan. And when I'm out in Michigan, that's a place I go every single day. Every day I go to Creation Coffee for my morning coffee. It's a little bit of ways, but you know what? That's okay. It's the same commute as it would be when I'm in Vegas or I'm in Superior. I always go get coffee. It allows me to clear my head. It allows me to have my commute. Even though I might be working from home, I still do a commute every day. And Michigan, I don't have a small commute, but This allows me to clear my head, go there, interact with some people, and then have a 2 cups of coffee, because that's usually what I do, because this is a large, and I get 2 large coffees, and that's how that works. That's from earlier today, so it's minorly less than warm, but that's okay. It's still tasty. It's 6:43 in the evening, but you know what? I'm okay with that on a Sunday, and I might have to pay for this when I can't sleep tonight, but that's okay.
From the contact from miles north of Wausau Airport.
That's okay.
Atlanta Lake via direct climb and maintain.
So that's my coffee today, and today, like I said, I got my phone connected to a wonderful secure mount to the ceiling. Really excited about that. And so an iPhone 15 Pro Max is connected to a Jobe phone mount with a Row intercom or a Row audio, wireless audio system, and then that's connected to a cable that's connected to my airplane audio system. And so now I can talk on my headset. I don't know if you can see that or not, but I can use my headset, and that's where the audio is coming from, which is coming from this box right up here called the intercom system. And so you don't have to hear the engine.
17, the squawk is 2410.
You don't have to hear the engine. You get to hear the audio from the radios, but that's there's no air engine. There's no air. It sounds a lot better. I think so. Anyway, it makes the video sound a lot better. And then this intercom thing. This is new for me. This is called. This is from PS Engineering Incorporated. Okay, and what that means is an intercom system or an audio controller or an audio panel is another term. In airplanes, we want to be able to talk to each other while we're flying airplanes without screaming at each other. And it's kind of loud in here. And so what we need is so start of all, you want to wear earbuds. And I don't know if you can see, but I got hearing protection on, right? So these hearing protection is actually called a headset. And the headset, the one I have anyway, is the Lightspeed, the newest one, Zulu something. And that connects to this intercom. So what this does is inside of the airplane, it allows everybody inside of the airplane that is wearing headsets and has a microphone to communicate between each other. The audio doesn't leave the aircraft at all. But what it does is it makes it so we can talk to each other in the airplane without yelling and screaming. And it has this thing called a squelch. And so what has to happen is I have to talk a little louder. And when I talk a little louder, it makes it so the intercom relays. Otherwise, without the squelch, it would only be picking up engine noise and wind and all that stuff. And so this applies to everybody in the airplane. And then other seats have other headsets. Of course, the headset you have to buy separately. I have this Zulu headset, and then I have some Bose headsets, and then I got some lower end ones for backseat people that are not as expensive, let's say that. And so the one I fly with right now, like I said, is a Lightspeed. I think it's called Zulu something. One thing I love about it is it has the carbon monoxide detector built right in. So it has it built in, I believe, in this little gizmo right here. And then also, this intercom system does this thing called noise canceling. And so it gets rid of, like I said, the prop noise, it gets rid of the air noise, it gets rid of all of the airplane noises, and it makes it so it's a lot more enjoyable. So that's what the headset does. Back to the audio panel. The audio panel also takes audio from the 2 radios that I have, these 2 radios right here, and then also takes audio from the nav side of them radios. So this side is the comm side, and this side is the nav side. And so we can switch that by these buttons here. Right now they're green. They're green, stating that they're on comm 2 right now, so we're listening, and then we're broadcasting on comm 2. There's these N numbers, and them have to do with listening to the nav side. Okay? I don't want to get into why you would want to listen to your nav radio, but that is one of the things that you can do with this wonderful intercom. Then there's a COM1 side, which is this radio up on the top. Airplanes have two radios, so then we can talk to one frequency and then listen to another one, or just simply have a
uniform, my frequency 3365.
Or simply have a redundancy. And so this intercom allows us to listen to our radios, broadcast on a certain radio, broadcast on both of them if we wanted to, like the passenger or the co-pilot over on the right side, and listen to a radio. The pilot on the left side can talk on another radio, so you can actually have a split, is what PS engineering calls it, is the split mode. They can make it isolated, so if I got little passengers and other people in the airplane, and I really don't want to hear them because, I want to focus on flying, I can come on this button right here and I can isolate each one of them. That works really well when I'm flying with, kids that get a little excited, and that's okay. So there's an isolation button here, and that's what that ICS button does, is it makes it so now I can focus on flying, the radios, and then if they want to talk to each other, they can. That's one of the modes with the isolation. A couple other things this intercom does, since it's the flagship of PS Engineering, and it's the PMA 450 Bravo. So Papa Mike Alpha 450 Bravo. And what this is their current flagship intercom system. And why this is important is this supports two Bluetooth sources. Two. So I could have a phone, an iPad, another iPad, let's say any other Bluetooth sources connected to source 1 Bluetooth, and then another Bluetooth source connected to source 2. The way I have it configured for myself is my phone is on Bluetooth 1, and on the event I'm on the ground, I can use my phone, which I don't do, but that's something else. I can use my phone on COM1 and have the audio go through the intercom system for myself, okay? Then COM2 is my iPad, okay? And my iPad, I love it with my iPad because now, if I use ForeFlight, which I do, when I'm entering a runway, when I'm getting out of a runway, or approaching a runway, when there's traffic, when there's terrain, my iPad Bluetoothly connects to my intercom system. So if I'm in the proper isolate mode called all, everybody in the airplane, and the distribution mode, I should say, everybody in the airplane can hear my iPad, and which is really helpful with that situational awareness. It's, let's say if I fly with another pilot, if that other person hears, hey, terrain ahead, at least it's another person to go, hey, terrain, or an obstacle ahead, or entering runways, it's another situational awareness.
Frequency get better, the more southbound you get.
Not just hooked up to my headset, where you can,
1841 Quebec, my frequency 3355, if you're not already there.
Over to 13355, 1841 Quebec. The center, Cardinal 1841 Quebec, level at 6.
1841 Quebec, thank you.
Some headsets, if you have the noise canceling Bluetooth mode, can do that too, but then it's only for one person in the airplane. I love this. Like I said, it goes to the audio panel. It connects every single time. I love that. So that's another feature of the PS Engineering PMA 450B. That's another thing it can do. Then it has another way of getting music in. So if I go inside of the mode here, I can actually have it, like in my case, I have a Sirius XM receiver. That's these little lights right up above. If you notice it flashing right here. I know it's dark, I understand. What this does is it makes it so my XM audio, my XM radio audio comes through my intercom, and then of course to everybody or who I choose in the airplane. We can make that selection here. I can have everybody listen to the music. and I can turn it on for you. There's the audio right there. I put it back to Bluetooth. Like I said, I don't want to leave the audio, the music on for you because it turns into copyright issues, so we're going to leave that alone. That's another thing that awesome intercom does. So multiple Bluetooth sources, multiple music choices. So it's even more exciting. We can actually get into detail about, I could have a passenger or a co-pilot, the person on the right, he or she can listen to their own music choices and Bluetooth choices. The pilot on the left can listen to their own music and Bluetooth sources, completely independent. And then the people in the back, same thing there. And so it makes that flight so much more comfortable. With me, I love my music. When I even work, I love to have music on all the time. And yes, I listen to electronic dance music, kind of weird. It'll calm me down, but I really, really like electronic dance music when I'm flying. And them are all the wonderful features of that intercom system. I love it. I just got that installed here a couple months ago, and I wasn't expecting to do it, but it had to be done because the other thing this device does is it takes audio sources from other parts of the airplane. So this gizmo down here, this device down here is called a Garmin Autopilot. A GFC500 is the official model number. What that does is an autopilot. It controls another piece of equipment, and then that piece of equipment controls little servos that are controlled by flight controls. And so I can tell this thing to take a source from different sources, and I'll get to that in a moment. They take the source, and then they fly the airplane. And what it does is a combination of this thing called a flight director to keep the wings level, and then it takes other sources like a heading, which is where we're pointing, or a navigation, which is the navigator here. We could actually also add it on to an approach, which it grabs onto a glide slope. What that is now the airplane can descend, and it can grab onto that and make it ascend. Autopilot will maintain altitude. So in this case, we tell it to maintain at 6,000 feet. Come down here on the autopilot, and we tell this green little area up here. You can't see it. That's okay. We tell the screen up here what altitude we want to go to, which is right here. And then we tell it also, push this button down here called altitude, and what it does is it will hold the altitude for us. So bare minimally, that removes a huge amount of workload from me. And second of all, I have this on nav mode. See this little button right here called nav mode. And what that does is if I have a course in here for my navigator, what I can do here is I can press nav, and then it will keep me on course. And what's beautiful with that then, that makes it so I stay on that steady line across the planet. So if I'm going from point A to point B, it will keep me on that line, and I don't have to think about pointing in a certain direction. It just does it and compensates for wind. And that's what's really beautiful when it connects to a navigator. So bare minimally, them two options right there make this so much easier to be able to be single pilot at nighttime. If I need to be in the clouds, I can, and I can have my workload substantially less to make, of course, videos like we're doing right now, which is even more awesome. So, there's that. But that is my other add-on, and how that connects.
Uniform pressure maintain 3,500.
And how that connects to the intercom is on the event I turn off my autopilot. And there's a couple different ways I can do that. It makes this auditory noise. So let's say the autopilot shuts off for some odd reason. Like I bumped the button, I just can't maintain because it's trying to go up and it wants to. It creates a stall situation. Like if I don't have enough power in, what it will do is actually say things like airspeed, or it'll give this indication like this doo 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 doo. And what that means is the autopilot has now shut off, and it alerts everybody in the cabin. Hey, someone's got to fly the airplane because the autopilot ain't going to do it anymore. And that was a requirement of that particular autopilot to be able to be certified. And so I'm really excited to get that. But with my old intercom system, that wasn't capable, so I had to get a new intercom. That's exciting, but that's okay. I wanted that new intercom, and I got the new intercom, I got the new autopilot, and it's amazing. It makes this airplane truly. I have now tucked it down from Superior, Wisconsin, all the way down to Las Vegas now, all in one day. It takes about 10 hours, 2 fuel stops, and it makes the flight so much better. Oh my. I made that flight a couple times by myself at nighttime without the autopilot. Yes, I can do it myself, but it's so much better to be able to do this now with an autopilot. Now I can focus on planning. I can worry about weather. I can worry about all the other aspects that come along with flying, not just maintaining level flight. And so this works out really well. And don't get me wrong, there's some opinions about, flying with the autopilot all the time. I can fly without the autopilot, and I have no problem. I do keep my skills up. Almost every single time I fly, I at least want to fly a portion of it without the autopilot, because you don't want to be dependent on technology, particularly with flying. That's the wonderful autopilot. What this little screen right here is what that is. It's called a navigator, and that's from Garmin, and that's where I put my flight plan. So I prepare my flight plan on my phone. So I call this the I usually plan my flight a couple hours before a flight, and I usually try to do it. That's going to sound really weird, but some of you will agree. I do my flight usually right before I go flying, and that I usually do that either in bed or I do it in the bathroom. So I'm not distracted. So now I can think about everything. I can lay out my points and be like, hey, I got to get from here to here. Well, sometimes there's going to be things in between, or I got to figure out a route that actually is safe or mountainous or terrain or weather or turbulence or icing or clouds. Or plainly just airspaces I want to avoid. There is so many variables when planning a flight. Plainly, what altitude I need to go to. I got to get the winds. I got to get the weather. I got to figure out timing. There is a lot of different variables I got to look into and think about. And I like to do that when I'm by myself and I'm not rushed, because truly you don't want to interrupt that process. I want to have a plan, a solid primary plan, and a solid backup plan, even before I touch the airplane to open the stupid door by the time I get to the airplane. So I do all of that in ForeFlight, and ForeFlight is a Boeing product. And ForeFlight is a piece of software only available on iOS, which is perfectly fine. And I lay that whole thing out in ForeFlight. I love ForeFlight. And I lay that whole flight out, then I save it on my phone and in ForeFlight called Flights. And then I go to the airport and I do my pre-flight inspection, pre-flight briefings. I also do my loading of the airplane. I have a whole ritual and a whole checklist that I do every single flight. And some of you that have flown with me, you understand. You've seen me do it. Like, wow, you have a place that you put your luggage. Yes, everything is on purpose. Everything has a particular order. I like to make sure everything is on purpose and has an order, and everything is uneventful. I don't like to be distracted when I do each one of these processes. It's intentional how I do that. How I load the airplane depends on the weight balance. Depends on the weight of the packages, where they load inside of the airplane, the passengers, where the passengers go, how we're going to talk about the passengers, how we deal with the people inside of the airplane, where they're going to sit, where we're going to put all the weight. I probably just said this 15 times. Let's see if you actually pay attention. So I think about all of that stuff, and I do it every single flight. And not just, oh, we're going to fly down and then come back, and that's one flight. No. A flight is every single time you take off and land is a flight. And that is one thing that's really, really important. You might go somewhere, and then you might switch things around, like a simple drop and go. So there's a couple times, or I should say there's a lot of times that I go somewhere like Mankato. So I'll go to or Flying Cloud or to, oh my gosh, so Mankato, Flying Cloud, Eden Prairie, Brainerd, Minnesota, any one of these towns. I'll go down there, pick up an individual, or pick up some sort of package for my business. That's it. I don't get paid to flight. I don't charge for my services. I'm not a airline pilot. I do not conduct a commercial operation at all. This airplane is to furtherance my business. And so I have to go all the way around the region to either go to a client, drop off something at a client, so that I can work on it.
Flight service, who's that?
And so if I need to go somewhere to work on a system or to have a meeting, that's the purpose of this airplane, is it's about getting me there, not for transporting of some sort of equipment or whatever. No, truly, I'm going there to do something. It's a furtherance of a business.
Yeah, either way, I got a cancellation, so just give the number.
And so there's multiple times that, I'll go somewhere and get back in the airplane. Well, I picked up something. So let's say I pick up an individual and person gets in the airplane. Well, guess what? I got to redo that weight and balance every single time. And it's something to really think about. So getting into checklist usage and all that stuff, when getting into planning, now that gets into that navigator again. So back to planning my flight. So a flight was on my phone, my iPhone. Then I get to the airport. I get in the airplane. I turn on my iPad, and you can see my iPad down here.
Contact Milwaukee approach 127.0.
The iPad has 4G in it, and then at that point, while I'm on the ground, what I do is now ForeFlight connects to my flight area that I had on my phone. Bring that flight into ForeFlight, and then once it's in ForeFlight on my iPad, I can connect my iPad to the navigator with Bluetooth. It's wonderful. So let's say it's something that has multiple waypoints along the way. I can plan it all on my iPad or plan it all on my phone and then push 2 buttons and it appears on my navigator without turning and pushing and entering. It's all right there on my navigator. It's really easy to do. And now at this point, my entire flight plan is loaded on my navigator. Okay. Then before I take off, I do my takeoff. Or I call it my Avionics checklist. And what that does is I load everything. So I load my frequencies. I load my music, of course. I load my route that I got from my iPad. I set my altimeter, or of course, my weather altimeter setting, like I talked about. I also set my altitude. And that was whatever I planned, and that's all in ForeFlight. No thinking necessary, just do what it says because that was the plan. Set my altitude and my this is called the G5, a Garmin G5. Set that. I set my climb speed, and I can set all that on my G5. I set my heading indicator to the departure runway, which is already planned, and I can talk about how to prepare for that. I set all of that information before we even taxi. So I know what altitude I'm going to climb to. Let's say it's something that's according to my flight plan, or air traffic control told me, hey, yeah, you can climb up to 3, but expect your, let's say, 10,000 after a certain amount of time. I load all of that even before I start taxiing. Where is that all from? My flight plan. That was where? Planned. Way before I got to the airplane. It's really important. So I set all that, make sure it's all set. I prepare this airplane so I don't have to remember anything. The airplane will remember it all. My iPad is completely separate. It remembers everything that I told it to do. And of course, some people are like, well, what happens if you have electrical failure or your iPad dies? Well, I understand. That's a great question, and you're more than welcome to criticize however that works. If my iPad dies in flight, I have my phone. Well, what happens with batteries? I have USB ports here. There's a whole USB port down here. I have USB ports down below. So that comes from the battery, the alternator from the airplane. I also have battery packs that I carry every single flight.
Yeah, I don't know.
So the chances of me not having a phone, an iPad, a charger are very low. Don't get me wrong. I've had an electrical failure in flight at nighttime, and you know what? It was not an exciting experience. And yes,
Remember 77 Bravo, contact Minneapolis.
it was an exciting flight. You know, at nighttime, all my electronics shut off. But you know what? The iPad still worked. The phone still worked. There was always a backup plan, a redundancy and a backup plan. I'm always thinking about that stuff. But anyway, so back to the route. All of the routes loaded. I expect when I take off, everything is set, so then I don't have to remember anything, and then of course forget it, because you know, once you're going on the runway, things can happen. Engine failure, electrical failure, something jumps out in front, a tire blows, a door opens, any one of these minor, major, emergency, urgent things that you don't want. I don't want to have to remember. Hey, we're what altitude are I'm going to climb up to? I remember. Oh, truly, everything is all on purpose. Everything is planned. Everything has a plan. Everything has a backup plan. And that's how I like to fly. It's like, well, what happens if this happens? I expect my door to open in flight. Okay, I just expect it. I won't get, I'm going to get startled. That's just to be human. But I know what to do. Do I have to abort? Do I have to not abort? What's going to happen if that door opens? What's going to happen if that engine fails? What's going to happen if a deer jumps out? What am I going to do? Now, them are all things that I'm thinking about even before I start taxiing. Always. It's really, really important. And if I fly with other pilots and or just interested passenger, you know, and I tell people, if you want to fly the airplane, you're more than welcome to. I'll show you how to do it all. That's not a big deal. I'm a certified flight instructor, certified instrument flight instructor. And I've taken a good amount of people up, and we've flown airplanes. And I tell people, I can tell you as much or as little as you want or you feel comfortable with. Some people get a little uncomfortable when we talk about grim realities, and that's okay. That's one thing I tell people is I'm going to talk about, I'm going to verbalize, I'm at least going to acknowledge, hey, what are we going to do with an engine failure? Hey, what are we going to do when we're going on the runway and I'm supposed to be off the ground or ground by this time? What am I going to do? How am I going to react? Or where am I going to land if I have an engine failure? We talk about all that stuff, or I talk about all that stuff before I take off. I want to have a solid plan. It's really important. By the way, the reason why I stopped talking is because I drink a little bit of water, so bear with me. So that gets into planning. Every single time I get in the plane, I know what my plan is. I know I have a backup plan. I know where I'm going to depart from. I know where I'm going to land at. With the technology.
25 Minneapolis Center, Sawyer 2347, wind 060 at 7, visibility 10, skies altimeter 3013. You can expect visual approach runway 1. Runway 1 approach lighting system is out of service. And descent to pilot's discretion, maintain 3,100.
I want to have a forward plan. I want to have a backup plan. Like, I want to know, I want to understand that, hey, things do come up. Like, prime example, I just realized that the field in Superior, the airport in Superior just went IFR because I bet you there's fog. And let's take a peek. Yep, it's fog. So there's fog coming off probably the lake, which it says. And so we're going to have to do an approach into Superior, Wisconsin. That was not according to plan, but you know what? I am current to do an approach. I am proficient to do an approach into Superior. I have done them manually in the past 6 months. I have done them manually in the past, it's probably been less than a month actually. I have done them manually with the safety pilot. I know how to do that. And so, yes, don't get me wrong. I'm going to use the autopilot to do that approach. Oh, for sure. Yeah, for sure. But this is something that's changed. But you know what? I'm ready for it. You know what? Yeah, sure. It got my attention. I'm like, ooh, what's that? And yes, now it's called IFR, which means that the clouds or the solid layer of clouds is below a certain altitude. And now that field is reporting instrument flight rules. So I got to deal with that, but that's okay. There's nothing to panic about. I have a backup plan. My backup plan is on the event I can't do it in Superior, and I have enough fuel to do this. I will go up to Duluth. If Duluth doesn't work, I'll go to Cloquet. And yes, don't get me wrong, I'm not real excited about that because then I got to figure out how to get a ride. But it is what it is. I'm not stuck in the airplane. I'm not going to just freak out and go, oh my gosh, I can't. No, truly, I have a plan. That is the plan. And in 45 minutes, that's what's going to happen. Or I guess 46 minutes, but because we got some wind. That's what's going to happen. And so talking about planning, it's okay. It's okay. There's no reason to panic. There's no reason to worry. We're going to work the problem. Always work the problem. Do the math. That's the number one thing I could possibly say about airplanes. Panic doesn't solve anything, but do the math. You will get an answer. And you might have to do the math again to go, do the math. It doesn't matter, you know, an astronaut said that one time, is you know what? You might not have a choice of landing. Think about this. A flight that goes to the moon. You can't just get on the ground and be like, oh, yeah, well, I'll just pull over. No, you can't just pull over in an airplane. You can't just pull over in a spacecraft. You have to figure out with the situation you're in and all of the variables, you got to figure out how to deal with it. Otherwise, you're going to die. I mean, honestly, it's really that simple. It's the same thing with a car, okay? You've got to figure it out. Now, in a car, your timing is a lot shorter. In an airplane, you got time to think about it sometimes, most of the time, I should say. In a car, you know, it's like, yeah, don't get me wrong, you have tire blow, you go over to the other side of the lane, and you're done for. I understand that. In an airplane, we have some time to calculate things. We do. Work the problem. Do the math. Be like, hey, you know, I right now, my math, just calculation is, in 45 minutes, I'm going to be in Superior, Wisconsin. And in 45 minutes, according to the math that I figured out before, the field was not going to be this way. But you know what? Now I got to redo the math because now in 45 minutes, the clouds are going to be below a certain point. So guess what I did? I looked at my airplane. I'm like, hey, all my databases are up to date. My airplane is certified for instrument flight rules. I am current. I'm proficient. You know, and the limit of the approach, the instrument approach in Superior, Wisconsin currently is still lower than the clouds. Again, perfectly fine, perfectly safe. And if that doesn't work, guess what? I'm going to go up to Duluth. And at Duluth, I can get down even lower. In Superior, without looking, it's a lot higher than in Duluth. But Duluth has, it's a lot, the obstacles are not as close to the airport and it's not as high. And so in Duluth, in this airplane, I can go down to 200 feet above the ground where I can see the runway. Where in Superior, I think it's closer to like 6. And that's okay. So that's the choice. Go up to Duluth. If I've done it before, and I hopefully don't have to do it tonight because it's just irritating for ground transportation. But on the event I got to do it, I got to do it. It is what it is. That's the funness. That's how the planning works, and it is what it is. So talking about the instruments inside of here, like I said, that's an audio panel up there. You know, I'm hoping that one day that you people can maybe anybody listening to this thing, you're more than welcome to come for a flight with me sometime. And you can hear the audio in here. This system. Oh, I love the audio quality. That intercom is stereo, and so another cool feature is I can have one radio be like the left ear and another radio be the right ear, so then now I can actually know who's talking with what. Oh, yeah, that's the excitingness there. I just took a drink of water there. And that's the excitingness there. Truly, I love it that I can have that audio on either left or right. You got to have the right headset to do that. Some lower-end audio headsets don't allow stereo sound. And then also you have to have the right jacks installed in the airplane. But It's so wonderful to be able to do that. True, be able to do that. It's wonderful. But that's the stereo thing. It works really well. I love it. But anyway, audio panel, 2 radios. Yeah, them radios from the early 2000s. They're called King KX 155s. And that, don't get me wrong, they're from the early 2000s. They would like to replace it, but they worked perfectly fine. And then I found out how much they were. And I'm like, you know what? They're even more perfectly fine. That's the radios there. That's the wonderful autopilot. Let's see if I can get this area down here. This is the throttle quadrant, is what it's called. In this airplane, there's only one engine, but it's still the throttle area. And then side up here, on the left is the throttle, and that's this knob right here. You push it forward to increase the power, and then to pull it back, it reduces the power. You put the power in, you take the power out. That's the motion there. Next knob over, that's called the prop control. And what that does is it controls the speed that the prop spins by changing the pitch of the airplane. So that's really cool, and I can get into that, but that's a different show, everybody. That's the prop control, and this is it slides in and out, and then it turns for fine motion. And then the instrument over on the knob over on the right, what that is called the mixture control. And what that does is the most easiest way I can explain it is it changes the fuel flow. So I can change that fuel flow depending on altitude, power settings, temperatures, all of that jazz. That's what the mixture does. And the same thing, just like the prop control, that pushes in for more power and then out, which is a complete cutoff. And then if you turn it, it's very fine. And what I can see that on my engine instrument here, that's this little screen right here, I can see effects of that mixture on this thing called fuel flow. That's what that does. That's the throttle quadrant. Over on the left here, as we can see, my finger, you probably can't see it very well, but it's there. That is the gear selector. And this airplane, of course, is a 1972 retractable gear Cessna Cardinal. And what this does is it allows me to bring the gear down or bring the gear up. And that's what that knob does. There's some lights over here that tells me if the gear is up or down. The yellow one right here, that means the gear is up. And then the yellow one right here, or right below it, there's a green one. You can see that. That means the gear is down. And so when I bring the gear down, I hold it down until the light turns green. And yes, that is the procedure. That is really, really crucial. If you bring the gear down, you grab that gear, I will not let go of the gear until the gear is down and locked. And I say that every single time I bring the gear down. So I'm like below a certain airspeed, I say below 135. Right now we're actually 135, so I could bring the gear down right now, but I'm not gonna. Below 135, gear's coming down. I grab onto the gear handle. I pull it out. I bring it down. I hold the gear switch down. I hear it go down. I see the light turn off. I wait, and then the green light turns on, and then I say, gear is down and locked. And then I move on, because it's part of the before landing checklist. And I do that every single flight, every single time when I bring the gear down. Every time. And then, of course, at every position when I'm coming into land, I'm like, I look at that stupid light. I lean over. When I land, I'm always sitting up front here. I'm like, gear is down and locked. That's what that green light means. And so I do that every single time. I do that in airplanes that the gear doesn't go down in. And that's just the way it is. Some people laugh at me. They're like, yep, the gear's still down. Yeah, that's nice. But I fly retractable gear airplanes. That's the major of my experience is retractable gear airplanes. Sure, I learned in a 172 or a Oh, what's that thing called again? I'm going to call it a 172 Skyhawk, just like almost a lot of people have. But in the grand scheme of things, yes, that airplane wasn't retractable gear. But in my airplane and in other airplanes that I have flown, heck, I have experience in a 172 RG. I have experience in a Piper Arrow, that's retractable gear. I have experience in a Cessna 210. What is that thing called again? I still can't remember. But that's a 210, and that's retractable gear. I have my twin experience, and that was a Piper Manchi or a Seminole, one of the two. I don't remember. I can't remember a lot. But that was retractable gear, so I do that same process every single time. Truly, it doesn't matter. The gear, got to find that gear knob. And that's that same procedure every single time. Gear is down and locked. Okay, let's move on. That's this little knob right here. You probably can't see it very well, but what that is the trim, the pitch trim. And what that does is, even if I had an autopilot and using the autopilot, what that does is alleviate the pressure from holding the yoke. So if I, let's say, pitch down in the airplane and I push the yoke really far forward, the airplane, if I don't change the pitch, it'll bring the nose up right away. Where if I change that trim, what it does is it makes it so now I don't have to hold that yoke if I want to maintain that particular pitch, is what that does. Most airplanes all have a trim. I've never seen an airplane that doesn't have a pitch trim. This airplane also has this thing called a rudder trim. And what that does is make sure that, let's say I'm flying along and I need to hold right rudder in a climb. The airplane wants to go to the left. Single engine airplanes have this tendency to want to go to the left, called the left turning tendency. You add power, airplane wants to go to the left. When you are nose high and have power, airplane wants to go to the left. When you adjust power to go from a low to high, the airplane wants to go to the left. The wind coming off the prop itself comes around the airplane, hits the airplane on the left side of the airplane, and so the airplane wants to go to the left. That's just what single engine airplanes want to do. And so when we take off and we are climbing, we have to use that right rudder. Well, in this airplane, sometimes the foot gets tired and you don't want to hold that right rudder constantly. So there's a little knob down here, or turn wheel, and I can adjust a little bit of right rudder. And so for a long climb, I can have, without holding in the rudder, which is a pedal, I can hold that in. I don't have to hold it anymore. And so that is called the rudder trim. So this airplane has a pitch trim and a rudder trim. Some airplanes have this thing called a roll trim or an aileron trim. This airplane does not have that. I don't want to talk about that. I know about it, but I've never flown an airplane that actually has that. So, but that's another type of trim. But that is that wheel right here, and then over on the left, probably can't see it because my iPad's there. Over on the left are some switches. Them switches are lights, so we can start with the left. The far right, we'll start with the right, the one on the right. The landing light, the taxi light, it's a split switch, and if we turn on the landing light, I turn on the landing light and the taxi light. That's just a simple switch up. The next one over is the beacon and the strobes, and again, there's actually one switch, but it's split, and it controls the beacon, which is this red blinking light on top of the airplane. And then, or it's actually slow, just like towers are, that red, that is the beacon, okay? Then in this airplane also, it has strobe lights on the end of the wing, and they strobe at the same time, so it's doom, 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 and it's about, so other airplanes can see the airplane is what both of them have to do with. It's this anti-collision ideas theory. Position line, they're anti-collision. I think is what I'm going to call them. Because particularly the beacon. That one needs to be on whenever you operate the airplane. And when it's safe to do so. Sometimes it's not safe to do so when you're in the clouds. It's kind of distracting, so it's not a good idea. Some pilots choose to turn it off in flight when they're in the clouds. That's their choice. But the strobes, you can turn them off too when you're in the clouds type of thing. But when you're outside, I like to have all of the lights on, particularly when I'm entering a runway, when I'm on a runway, when I'm coming into a particular airport. I like all of my lights on, my taxi light, landing light, my beacon, my strobe lights. I like all of that stuff on. Then there's another switch down there called the nav lights. And just like in a boat, there is a green light, and that is on the right. And then there's a red one on the left, and them are solid. And then some airplanes have a white one in the far back of the airplane, which points backwards, and some airplanes have that. But what that has to do with are your nav lights, and you need to have them on at nighttime. And I can define exactly what that means, but we're not going to get into that. The FAA requires that you have them lights on, just like the boats. When it's nighttime, you got to have the night lights on. And that's the next switch over. So landing light, taxi light, beacon, and strobes. What was that one called again? Oh, yeah, the nav lights, and then the pitot switch. Pitot heat is what that switch does. And what that is there's a little heater, a little piece of metal sticking out of my wing. And what that device does is it picks up ram air pressure. So air comes into this tube, and it tells this instrument how fast we're moving through the air. And that's called a pitot tube. And if there's icing, let's say for some odd reason I decided to fly this airplane in icing, and I picked up icing. That could stop working, and that would be really important. It is really important to know your air speed. What I can do is I can turn on this thing called the pitot heat. And what that does is a little heater, electrical heater, and it heats up the little tube, and in theory, it can melt the ice that's on the tube or prevent the ice from happening. It's there. I test it. We test it every pre-flight. I know it works. I don't use it I've never used it because I do not go in the clouds that there's a chance of icing. I do not plan on going out icing conditions. I do not go in the clouds when there's icing conditions. So the chances of me using it are very slim, but it's there on the event something weird happens.
That altitude does check, and you are going to 88 Charlie. Frequency coverage in the next 15 minutes isn't great, so if I lose you, next frequency would be 124.4, 1244 in 2020 minutes.
That's the next switch over down here. And then there's some knobs. There's two little resistance-based knobs, potentiometers. They have to do with, I'll turn, you notice, they turn on the brightness. The brightness, the red. There's some lights up here that actually are creating that red, and that's what you're seeing there. And that's what them are using. I use them when I fly at nighttime. And then the next item over is the key, the ignition key. And then the next switch over is there's a fuel pump there. I use that for priming the engine, and then also it's a backup fuel pump on the event the engine one fails. And then the next switch over, it's a big red switch. And what that is called the master switch, and that actually is what turns on all the equipment on the airplane. And then a little bit farther over, there's another knob, and that little knob is, I just pulled that out actually myself. What that is a vent. And that vent opens up a little door on the side of the airplane, and what that does is allows air to come in into the cabin. And so, like I have a heater over here, and I'll talk about that in a second. Well, the heater heats up the airplane quite well, actually. And so what I do is I open up the vent and then turn on the heater, and it mixes the air. And it's a little bit more enjoyable, not so hot. And then, like we talked about with the heaters, so over here, there's two knobs right here. And what them knobs are, the bottom one is, what it does is it redirects air from the engine and brings it into the cabin. And so it's warm air. Actually, there's a exhaust pipe, right? There's a box that sits around the exhaust pipe, okay? And what that does is that box is connected to some piping and a little flapper, and that little that handle down there connects to the flapper. And what that does is it allows air to come around the exhaust pipe, not with the exhaust, and into the cabin. So that's actually how we get heat in the airplane.
1841 Quebec,
Second.
contact Duluth, approach 125.45.
Over to Duluth, 1841 Quebec. Good day. Duluth approach. Cardinal, 1841 Quebec, level at 6.
Cardinal 1841 Quebec, Duluth approach, Duluth altimeter 3006. Advise you have the weather at Siri and approach with.
I'm looking at the weather, and I'll probably do an instrument approach here. I'll let you know here a little bit. 24 Quebec.
Cardinal 41 Quebec, last transition is pretty broken. I heard you were picking up the weather. What'd you say afterwards?
I'll let you know what the weather here in a little bit. 1841 Quebec.
Cardinal 41 Quebec, thank you.
What was I talking about now? Oh, the switches. So the heat. Exhaust pipe. There's a box that sits around the exhaust pipe, and it comes air into the air comes in through the front of the airplane, and there's a pipe that comes down and connects to this box. That air then goes across exhaust pipes and then goes into a little valve, and that little valve is controlled by that handle, and then there's another pipe that comes in, goes through the firewall, and brings that hot air into the cabin, and that's what heats up the cabin. And that's what this knob does. The knob right above it, what that does is it redirects that hot air through a vent up on the dash. And what that's called is the defrost. So now that hot air comes in, and instead of coming down below, it comes up. On the event there's frost on the window, hopefully not ice, but frost happens. As much as I hate to admit it, it does happen. What happens there is, I'll get in the airplane in wintertime. Of course, the human breathes, right? And the moisture from my breath will freeze to the stupid window. And that has happened multiple times. And what that does is it works really well to melt that frost. And also, it can get rid of inadvertent ice. And I can't believe I'm going to use that word, inadvertent ice. No, ice is always on purpose. It's just the question is, did you realize it or not? But it can melt a little bit of ice if you ever get it on your windshield, so you can at least see. And really, it only melts a small little portion. And it's not a good time when that happens, but that's what it's for. And so that's what that defrosting does. And then over on the right in this area over down here, there's a switch, and that's called the radio master, or a new term is called an avionics master. And what that does is it turns on my radios. It turns on my intercom. It turns on my navigators, my autopilot. It turns on another one of my G5. It turns on all my USB ports. It turns on my Sirius XM receiver. That's what that switch does. And you turn that on after you start the engine. And you turn that off before you kill the engine at the end of the flight. That's what that switch over there is for. Also down there's a bunch of circuit breakers for all the equipment. And so almost every single one of these pieces of equipment has an independent circuit breaker depending on the load of each piece of equipment. It can range from 60 amps, which is the alternator output, all the way down to I think it's like a 2.5 one for some equipment. Each one of these USB port devices have their own fuse. The intercom has a fuse. Each radio has a circuit breaker. The flaps, that's what this knob right here is, and I'll talk about that in a moment, has a fuse. Everything has a circuit breaker. Some of them are like you can pull them out manually. Some of them are simply when they pop out, you have to push them in, but you can't pull it out yourself. That's not all equipment over there, and of course this right here over on the right is the yoke. What I'm looking at down there is over there. Oh, let's see here. Okay, there's a knob right here. What that is the flaps. It's a flight control, called a secondary flight control, and they're on the back of the wings, on the inside of the wings. And so the wings are like this on the outside. We control them from the area from the yoke, and the inside there's these things called flaps. And what we use them for is takeoff and landing. And what that does is changes the shape of the wings. Is what that's for. And so there's different, like they can come down at different degrees, 10, 20, 30 in this airplane. So that's the flaps there, and like I said, a USB port. There's 5 USB ports on this particular piece of equipment, and the ones on the outside are all high amperage, high output. The one on the inside, what that does is allows me to hook up a USB drive to my engine monitor, so I can get values and do calculations and graphs and all of that cool stuff. It pulls that data from there, and that's what the inside USB port's for. This wire right here, this connects to my XM radio that's up on the top, and that's what powers that. And then this little gizmo right here, you can see that. What that is the hops time. When I turn on the master switch, particularly in this airplane, what that starts is it counts hours, actually tenths of an hours. And that's what we based airframe time on, flight time on in this particular airplane. Now, there's a difference between switch on or hops time and flight time, and there's a whole conversation about that, and it's legally defined. And so I like to cover that a little bit. We don't always use this for flight time, but that is airframe time. Let's just say that. Okay, we talked about all the equipment down here, and now we can talk about all this other stuff over here. By the way, I'm 19 minutes out, so I might as well get the weather here. According to the TAF, there is the forecast. This was not projected at all, so I'm kind of annoyed at that. But we're going to get the weather. We're going to listen to it's called the 1-minute weather.
4, visibility 10, ceiling 500, overcast, temperature 7 Celsius, dew point 6, altimeter 3008. Superior, Richard I. Bong Airport, automated weather observation 0043, Zulu, weather, wind 040 at 10, gust 14, visibility 10, ceiling 500, overcast, temperature 7 Celsius, dew point 6.
All right, so we got the weather. We got what the weather is the an automated thing that just repeats over and over and over again. Every minute it does this. And so the weather, I'm going to read it off my iPad. It might have changed from what it said on there, but the weather at my iPad, or called from XM radio or ADSB weather, actually that's the official source right now, is the, not official, but the source I'm reading right now is ADSB weather. At 7:15 Central Time, the wind was coming from 050, so that's northeast. I put that up here. Don't get me wrong, some of you people are like, what are you talking about? That is a VOR head. No, that's a CDI. That is for navigation. No. I understand. I use this to put in what the current wind direction is and the wind. I use it for that purpose. We're not using this for today's flight, and I use this to just document the wind. So when I come in for landing, all I have to do is look up and go, hey, oh, the wind is coming from 050 at whatever knots. Oh, okay, it's right there. I don't have to write it down and try to find it. It's blatantly right here. Might have an opinion about it, that's fine, but that's what I do. So the wind was 050. 12, so sustainably at 12 knots up to 18. Like I said, the weather, the thing on the radio was a little different, so I'm going to put it back to what I heard in the weather, because that's actually sooner, or quicker. Visibility was greater than 10 statute miles, which is the miles that everybody in the United States uses. The clouds, however, a piece of equipment shoots up and measures the height of the clouds, and them were 500 feet overcast, which means the beam did not go by, and it measured 500 feet. Temperature was 7 degrees Celsius or 45 degrees Fahrenheit. Most things in aviation are knots or nautical miles, and then they're based on centigrade or Celsius. Okay, the dew point was 6 or 43 degrees Fahrenheit. The altimeter setting was 3008, and I got all that. The humidity was 93%. That's an iPad thing. But now we have the weather. I noted, that's all I'm using these for, is the wind direction and the wind speed, or called velocity. We did that, and we're going to prepare to do an approach. Right now it's 040, which means what we want to do is we want to find a runway that matches this number as close as possible. So in Superior, we have 32, we have 22, we have 14, and we have runway 04. Okay, well, runway 4, it's close to that number. Yeah, we're going to do runway 4. Simple pilot math, like it's coach. 32 is down here, not that one. 22 is right there. Yeah, let's not do that one. 14 is over here, and 4 is close to 3. That sounds great. Okay, good. By the way, these little you probably can't see it, but there is some notches there. You can see a 3 right here, and that is one more notch is 4, and that's how that works. So 4, and the wind speed was, the gust was 14 knots. So I put that down here, 14. And I know you can't see that well, and I understand that. Okay, so that's there. Now we're going to do an instrument approach on runway 4, because that matches up that makes the most sense. We're going to brief this approach. I'm going to do it, but just manually in my head. We got the weather, we got the loop approach, clearance. They're going to tell us a clearance number when we get on the ground, 124.8. The Unicom is 122.7. Already talked about the missed approach. I'm not going to get into that with you guys. And what I want to do is I want to go to this fix called Barham, which is a waypoint in the air defined by GPS. So I'm going to tell Duluth approach, and I would like to do the RNAV 4 into Superior, direct to Barham, to set up for an approach. Duluth approach, Cardinal 1841, Quebec. I have the weather in Superior, and I would like to do the RNAV 4 and direct to Barham at this time, if I could.
Cardinal 1841, Quebec, descend to pause discretion, maintain 4,000 for now. Proceed direct to Barham for the RNAV 4 approach Superior Airport.
Down to 4 and direct to Barham 184, Quebec. All right, so now they've given a descent down to 4,000. We're at 6, so I turned this knob, and I brought this down to 4, and then I'm going to load the approach on my navigator, runway 4, transition, Barham, and then we're going to activate the approach. Airplane actually turns, if you're noticing. You really can't notice, but that's okay. As you can see on that instrument over on the left, airplane's actually turning because of the autopilot. I'm not doing it. Okay. And then we'll go down to 4. Some more button pushing already loaded. 4,000. So then now what I'm going to do is I'm going to do vertical speed, and I'm going to bring the nose down. And that's what I did here, all with the autopilot. I'm going to lower that actually. With approach Cardinal 184 Quebec. Was that up? Pilot's discretion.
Cardinal 41 Quebec, A firm pause discretion out of 4,000, direct Barham.
direct bearer and PD down to 4, 184. Why that's important, I wanted to acknowledge this for a second, is if they give you an altitude, they're expecting you to go at a certain speed, and then off the top of my head, it's a lot faster than 200 feet per minute. And so they said pilot's discretion. What that means, or PD, that means is I can go down anytime I want. I can go down at any speed I want. I can level off anytime I want, but I can't go back up. So you can go down anytime you want, at any speed you want, vertical speed, and I can level off whenever I want. And I can do all that math myself. What that really does is alleviates the controller from doing all of that. Some are different, like if I go to Minneapolis, what happens here is like a controller will be like, oh yeah, descend down to 4. You know, okay, what that means is, yeah, do it now, do it now. Because of whatever reason, the timing issues, there's another airplane at that same altitude or going to be, like there's reasons for that. But in this case, he gave me a PD, pilot's discretion, and what that means is I'm going to take my time. It is nighttime. I want to be as high as possible in the airplane. I want to be as high altitude as possible. And I want to get down eventually, but I have 11 minutes, and this is what this navigator is saying here, 11 minutes, 11 minutes, 45 seconds to get to 4,000 feet. Well, I was at 6,000 feet. I need to go to 4. Well, if I go 500 feet per minute, it'll take me 4 minutes to do that. So, okay, 1,000 feet per minute. That's 2,000 feet I got to go down. So 6 down to 4, that's 2,000 feet. If I go down 1,000 feet per minute, that's 2 minutes, right? Well, if I do 500 feet per minute, that is now 4 minutes. If I go down to 200 feet per minute, that is now 8 minutes. If I go down to 100 feet per minute, that's actually 250 feet. Now divide that to 250, I don't even know now at that point. It's now like almost closer to 16 minutes because I'm just keep doubling it. That's why we're descending at 100 feet per minute instead of 500 feet per minute. And we'll recalculate all of this. I mean, heck, we're at 5,400 feet right now. We need to get down to 4. We got to do that in 11 minutes. Everything's all good still. I'm just happy. Now, in the event I need to increase that vertical speed, I'll do that, and that's okay. And that's what's beautiful about the pilot's discretion. I wish I could show you guys, but over in Superior, I could definitely see a layer of clouds right over Superior. So this will be, it definitely exists. And so this will be exciting. How about that? But anyway, so looking at the approach plate, we want to be, we want to cross Barham between 8,000 and 4,000, where we're going to be down to 4. That's what the guy said. The controller said is at or above 4,000. And you know what? All of this timing will work out great for this purpose. Our minimums in this case, our airplane is capable of what's called an LP, localizer performance approach. And what that means is I have to be able to see a portion, I have to see the approach lighting or something, or the runway as at least 1,060 feet. And then I can commit to land. It's called an MDA, a minimum descent decision altitude. Minimum descent altitude. Of course, I should know that. I feel bad that I can't remember that, but this is an MDA. 1,600 feet. I'll load that here shortly. And there's a diagram of the airport over on the right. You guys can't. Oh yeah, a little bit there. Okay. You can see my airplane right there. Little symbol. So I'm going flying toward this little point right here. My airplane right here. And we're going to go over here. And then what's going to happen, I get there, going to turn inbound, should fly outbound. If I get clear to go direct, then I'll fly inbound. But it should be better to fly here and then go outbound and then come back. That's the right way to do that unless I get clear something else. And then I'm going to descend according to this profile view. Actually, I'm going to load the autopilot, and the autopilot's going to capture this proper descent path, which will work out really well. That's our plan. And if that doesn't work, we'll go up to Duluth, and that's what we're going to do. Do a nice little fuel check. We got 18 gallons on board, so a roughly estimate. So to be very cautious, we have 1 hour, 1.5 hours of fuel left. Yes, it actually is closer to 1 hour and 45 minutes, like 50 minutes. But I at least tell my head, hey, I got 1.5 hours of fuel left, and that matches my actual fuel tanks, which is great. I got 20 minutes of fuel, or 20 minutes of flight. If I go up to Duluth, I'm just going to add on another hour. So still, we got enough fuel to go to Duluth. That was not the plan, but that's okay. It was not forecast, so I didn't need an alternate. There was no chance of this. There was no forecast at all saying this was going to happen, but we have enough fuel. We have a plan. What that beep is telling me the autopilot or this screen were 1,000 feet from our altitude that I put in the G5. It's going to beep again here when we get closer to 200 feet. That's normal. And that's go through the autopilot. I mean, the intercom and the autopilot. So we go ahead. Got a checklist here. Phase of flight we're at is we're in a descent phase, so we're going to do the descent checklist. Throttle as desired, so I'm going to bring that back down to 23 inches because we keep on losing, or we keep on gaining a manifold pressure when we descend because the air gets more dense. Propellers that we're going to bring that to 23.
141 Quebec, reaching Barrow, cleared RNAV runway 4 approach Superior Airport.
Cleared for the RNAV 4 approach into Superior. Do you want us to do a turn?
Cardinal 1841 Quebec, K-firm, or I can vector you to give you the straight in. Either one works for me.
If you can give me a vector for straight in, that'd be awesome. 1841 Quebec.
Cardinal 1841 Quebec, cancel approach clearance, maintain 4,000, fly heading, let's go 230, vector for a straight in RNAV runway 4 approach, Superior Airport.
Canceling the clearance, and then a heading of 230, and I'm down to 4, 1841 Quebec. So what I did there was, instead of wanting to do the turn, what he's going to do is give me a vector, which is even better. It's going to come back out a little bit more, which is really awesome. More time, more planning, more thinking. More preparedness. So I intentionally asked for a vector, so he's going to give me a vector, how that's going to work. And then here in a little bit, I'll reload the approach is the idea. See, I'll do it right now. So approach, transition, vectors, and activate.
Information, Victor, current altimeter 3006.
Okay, so now,
Here's 86 Mike Juliet, IFR, level 9,000.
We're now using heading mode, so we're pointing in a certain direction now. We're heading to a certain area.
3006, 86 Mike Juliet, thanks. 86 Mike Juliet, as you have information, Victor at Duluth, and you can expect Victor's visual approach runway 9er, unless you have an approach request.
We'll advise with Victor, and visual 9er is just fine for us, 86 Mike Juliet.
Sounds good, thanks.
This is going to be an approach. There's nothing to be excited about. There is nothing proper planning, proper procedures, proper performance. It'll end up to be a successful, safe flight for the airplane, the passengers, and for everybody around.
GFC500.
Gears down, gears down. Gears down and locked. All right, minimums 1,100, airports in sight, autopilot's coming off. The white, 4 flaps. All power restriction, restriction.
Traffic now 12 o'clock and 4 miles opposite direction, 2,700.
Traffic in sight for 86 Mike
Gears
Juliet.
down, gears down.
6 Mike Juliet, Roger, report the airport site when able, 12 o'clock, about 60 miles.
Guess it's windy, a little bit of airspeed.
Airport in sight for 86 Mike Juliet.
Gears down.
Visual approach, runway 9 or 86 Mike Juliet.
6 Whiskey, Apple Center 121, 05.
6 Whiskey, you too, sir. 2105 for center. Thanks.
Bit of updraft. Gears down. Slowly bringing the power to idle. A little bit. Ups up. Staying on the center line.
Over to Tower, 18-3. Have a good night.
A little bit of back pressure on the choke. Field approach. Cardinal 184 in Quebec on the ground. Can cancel.
Cardinal 4, Quebec, to approach you, call.
Cardinal 184 in Quebec. Like to cancel at this point. I'm on the ground. Superior.
Air 4, Quebec, Roger, I-4 cancellation received. Thank you, have a good night.
You too, bye.